Uh, Hello guys. Today's video will be the second video of my series of on 8086 assembly with MASM. And in this video, we'll look at drawing graphics to the screen. So in the previous episode, which I recommend checking out, I made a Hello World program and I ran it in DOSBox. And as you can see, it outputted Hello World to the console. But now we're going to learn about graphics. And so we learned the basic concepts of assembly, of 8086 assembly language in the previous video, so I highly recommend checking that out. But in this video, we're going to talk about another interruption 10H, which allows you to create graphics. So I'm gonna go into here and I'm just gonna search up int 10H. And the first link should be to the Wikipedia page for this interruption. So what is this pop-up? Stop bugging me, pop-up. Okay. So first we want to create some graphics. So what we want to do is we want to write a graphics pixel. That's what we want to do. And again, the function number is an AH. So if we want to draw a pixel, so it will, where is it? Write character, read character. There we go. Write graphics pixel. So this is int 10H function ch. So we can see that the function number goes in AH. So we can go back into Notepad++. So let's open up Notepad++. And then we can remove this Hello World program. And then we can also remove the data segment. Actually, we might actually keep the data segment. I'll just make the data segment empty for now. So there's nothing in the data segment. So anyways, we need to get to coding. So let's go back to the int 10H page. And as you can see, we have like h equals to 0ch. So again, we use the move instruction. We're moving into the AH register the function number, which is 0ch. Next, now we need to supply the arguments. So, let me just see something from here. Before we actually draw the pixel, we actually want to do a bit of setup. We want it to be in graphics mode, not in console mode. In console mode, we just like write text to the terminal. But in graphics mode, it's going to open up a page in which we can draw. And so, in order to do graphics mode, I'll go back to the int 10h. For some reason, the tab got deleted. Int 10h. There we go. So yeah, in order to get into graphics mode or video mode, as they like to call it, we want to it's function 0. It's the 0th function, or the first function rather, I should say. Okay. So basically we move, and before we draw the pixel, we want to move a 00h in order to call function 00h, which sets the video mode. Then, let me see here. Argument. It has one argument, and that is the video mode we want. And the video mode we want actually goes inside the AL register, so that's where the argument goes in. And we want video mode 13H, and this is the best mode for graphics. This is the best graphics mode for beginners, but eventually you'll have to start using a lot of graphics modes. But this 13H is best for beginners, and because you're probably a beginner if you're watching this, we're gonna use that. We'll eventually get other graphic modes. But now we actually want to do the interruption, and this is just int 10h. And then I'm pretty sure we need to do something else. I forget. That's why I just used this other project I created as a template. Okay, so let's go back into int 10h. Oh yeah, so we need a palette. So we need to set the background color. So basically there's this function. So the function number is 0bh, as you can see, to set the background color, 0bh. And then the function number to set the palette is also 0bh. But two functions can't have the same function number, or can they? The BH register actually has two jobs. One, it can be used as an argument for a function. But two, the BH register can be used to define a function type. So for function 0bh, the BH register is being used to show the function type. So when BH is 00h, the function type chooses to set the background color, and function type 01h, function number 0bh, sets the palette. So we want the function type to be 00h, and remember, if BH isn't being used as an argument, it's being used as the function type most of the time. And so, in this case, it's function type 00h. So we want to move 00h into the BH register. And we can actually, and so let's do this. BH equals 00h, alright, and h equals 0bh. So let's go in here into Notepad++, and then we move AH 0BH, and then we move BH 00H. And then if I go here, yeah, and this function takes in one argument. And this argument goes inside the AL register. And this argument is the background color we want. In this case, we want black. So we actually need the single digit hexadecimal code for black. So you uh, so over here you might see like a color link. That's the link we want. So like we have a color link, color. You can click any of these color links and you can see the single digit hex code for each color. So for black it's 0, blue it's 1, and so on until F is for white. And so uh, and so we want the black. We want the background color to be black. So the hex code for black is 0. And so, and also I hate you pop up. And so, we can use it in the background color. So we can use 00H, which is the hex code for black, in our background color. Remember, the first argument is the background color, and it goes on the AL register. So we can do move AL 00H. And finally, we do int 10H in order to do the interruption. Now we actually want to write the pixel. We got all of the stuff set up. So let's go back to int 10H. So let's see. We're in write graphics pixel. And this is function number 0ch. So we can do move AH 0ch, and that's the function number to write a pixel to the screen. Next, this takes in 1, 2, 3, 4. This takes in 4 arguments, and the first argument is the color we want, and it goes inside the AL register. In this case, I want a white pixel, so I'm going to go into color, and the hex code for white is F, or in assembly we would write 0FH. So we can do move AL, which is the register in which the first argument goes in, 0FH. And there we go. We have the first argument, the color we want, inside the AL register. Okay, let's go back to see what the other arguments are. Now, BH is the page number. And when we do this whole setup over here, it actually creates a page. And so the page has a number. So there's like page 00H, page 01H, page 02H, page 03H, and the page numbers start at page 00H. And that means the first page is always page 00H. And so that means that the page we created is page number 00H. So we can do move, and let's see where this page number argument goes in. Okay, so the second number goes in the BH register. So we do move BH 00H. All right. Now, let's see what the next argument is. The next argument goes inside the CX register. That's the X position of our pixel. I want it just to be in position 10, comma 10. So 10 on the x-axis, 10 on the y. And 0, comma 0, which is just 0, comma. If you're familiar with vectors, you know what I'm talking about. But 0, comma 0 is like at the top right corner of the screen. And then 0, comma 1, you know, like, and then 0, comma 0 is at the top right of the screen. And so because of that, if I have like 0AH, 0AH, that'll place it somewhere near the top right of the screen. So that's what we want. So in CX, we have the X position, and in the DX register, we have the Y position. So we do move CX 0AH, and then we do move DX 0AH, and then we do int 10H. And basically, now we've written a graphics pixel. But it's best to store stuff in variables. Like, like from when you learn C or C++ or Python or JavaScript or any other language, or almost any other language, you learn to store stuff in variables so you can change stuff without actually like going into the hard code, just by changing the value of a variable. So in this case, it's going into the CX register. And the CX register can actually store 16 bits or 2 bytes of information. And if you remember from the previous lesson, you know that 2 bytes is a word. And in order to define a word, we use the DW instruction. So now we can do position X DW 0AH. And then we can do the same for position Y DW 0AH. And now we can replace this with position X, and inside DX we put position Y. Let me see if I haven't accidentally flipped it. No, I haven't accidentally flipped it, so this is fine. Alright, so now we have our data segment in which we've declared our position X and position Y variables. And in our code segment, we first assume that all of the different segments in the program have these registers which store them. Then we actually tell the code if you find something from these, just access it from the register. Then we turn on graphics mode. Then we actually set the background color, and then finally we draw our pixel. So those are the different parts of our main procedure. So now let's open up DOSBox. This one has already been utilized in a Hello World program, so it's now garbage. So I need to open up a new instance of DOSBox. So let me open up this new instance of DOSBox. I'll delete this window or minimize it, because if I delete it, it'll close all of DOSBox. And now I just need to mount a C drive again. So we do mount C colon backslash users backslash your username backslash desktop backslash the name of the folder you stored the 8086 assembler in backslash. And then we enter our C drive by just doing C colon backslash. And then we do masm slash a tutorial. Oh wait, but first let's just save it. Control S. I should have saved it beforehand, but anyways, let's do tutorial.asm. Alright, so this is just telling us that the object file we're going to generate is going to be called tutorial.object, and it's going to guide us to a setup in which we can rename the files generated from this procedure. We just want it to default, so we'll skip the setup by doing a semicolon. As you can see, there are no errors. So now remember, the object file is tutorial.object, so we just do link tutorial.object. And when we link an object file, it gets converted into an executable which we can run. And so link tutorial.object. And then we do a semicolon to skip the setup again. And it tells us that our run file or executable file will be called tutorial.exe to run it. We'll just do tutorial.exe. And as you can see, we have a beautiful little pixel on the screen. So I hope you enjoyed this. In the next lesson, we'll get to writing text and keyboard input. But anyways, bye.